In this video, I am focused on freely falling objects. This is the fifth of 7 videos in my Unit 2 titled Kinematics. If you want to practice what is covered in this video, then check out the video description. You can find a link to my worksheet 2.05 as well as video answers for each problem. What is a freely falling object? There are 3 conditions. The first is that the object is in the air. The second is that the object is not moving horizontally. It is moving in the vertical plane only. And third is that the only force acting on the object is the force of gravity or weight. Now in real life, falling objects will experience air resistance, but in most Physics 1 courses, we do not consider air resistance, and that's what makes them referred to as falling freely. Next, looking at reference frames, remember that some of the kinematic variables are considered vector quantities, meaning direction is important for them. For freely falling objects, we are often analyzing their velocity, acceleration, and sometimes their displacement. Freely falling objects move only in the vertical plane, so the directions are upward and downward, and I think which is positive and which is negative in most cases will be what you expect. Let's set upward as the likely positive direction and downward as the likely negative direction. Next, let's analyze graphs of motion. Here we have a person holding a basketball while standing on top of a building. The ball is released from rest, and the goal is to create graphs of position, velocity, and acceleration versus time for the ball while it is falling freely. Remember, for freely falling objects, the only force acting on them is the force of gravity. So we want to start our analysis as soon as the person releases the ball and stop the analysis right before the ball hits the ground. Let's start with the position versus time graph. I will set the height to be equal to 0 meters at the ground, so this ball ends at the height of 0 point. That's why I'll begin with a y-intercept above the ground, and the ball will approach the height of 0 or the origin at the end. As well, this object is speeding up as it falls. Remember that the slope of the position time graph represents the velocity, so to show that the object is speeding up, I want to draw a slope that is getting steeper over time. Next, looking at the velocity versus time graph, because the ball is released from rest, it should start with a velocity of 0 meters per second, so the velocity graph has a y-intercept at the origin. This ball is speeding up and doing so in the negative direction, so observe that the graph line is leaving the 0 point and moving into the negative quadrant. And because Earth pulls on the ball at a constant rate, that would cause the ball to speed up and increase its velocity at a constant rate, and so this graph should be linear in its shape. For the acceleration graph, remember that the ball is moving in the negative direction and speeding up, so its velocity is becoming more negative as time elapses. That would mean we have a negative acceleration and a constant acceleration, again because Earth is pulling on it at a constant rate. Another way to draw the acceleration graph is to remember that the slope of the velocity graph is the acceleration. I see a constant negative slope for the velocity graph, and another reason why we have a constant negative acceleration. Let's talk about the initial velocity variable. I will use the same person and basketball example, and there is 3 ways that this person can make the basketball a freely falling object. They can drop it or release it from rest, they can throw it upward, or they can throw it downward. In each case, as soon as the ball leaves the person's hands, it fits the 3 rules from the beginning of this talk, and the ball is said to be freely falling. When it is dropped or released from rest, the person is not starting the ball with a velocity, so we would want to plug in 0 for the initial velocity in case number 1. In case number 2, now the person is starting it with the velocity, specifically in the upward or positive direction, so we'll want to use a positive number for this initial velocity when we plug in for it. When the ball is thrown downward, again the person is starting it with a velocity, but now doing so in the downward or negative direction, so try to remember to plug in a negative number for the initial velocity variable in case number 3. Next, looking at acceleration due to gravity, sometimes referred to as free fall acceleration. All freely falling objects near Earth fall with a known acceleration value. The variable for acceleration due to gravity is lowercase g, and the value is negative 9.8 meters per second squared. Now the negative is there because Earth always pulls in the downward direction. It will never push an object in the upward direction, so acceleration due to gravity is always a negative number. In many Physics 1 classes, there are 2 different question styles, those where you solve with numbers and those where you solve in variable form. If it is a numbers-based question, use negative 9.8 meters per second squared for the acceleration variable. And if it is a variables-based question, use negative g for the acceleration variable. Let's talk about mass and freely falling objects. Here we have two objects, one of mass m and another with twice the mass, 2m. They are released from the same height and at the same time, and we are not considering air resistance. The question is, which one will reach the ground first? Well, something to know is that in the absence of air resistance, all freely falling objects accelerate at the same rate, so these will be picking up velocity at the same rate, and they will hit at the same time. As we look back over the kinematic equations of motion, observe that there is no variable for mass represented, so that would be reason to believe that mass is not a contributing factor when considering the motion of freely falling objects. Let's end with an example problem. Here we have a ball launched upward from ground level with speed VO. The goal is to determine how long it will take the ball to return to ground level, so we are trying to derive an expression for how long it will take in terms of variable VO and any fundamental constants. If you want to pause the video and try this problem on your own, resume when you are ready, and I will talk you through the solution. This is a question of how long, which means that we are solving for time, and that is one of our kinematic variables. We also have information for other kinematic variables, so we're going to want to use our kinematic equations, and we always want to start those with a vertical list like this. Remember that our analysis is in the y-axis, or the vertical plane, and we should be considering these positions as initial height and final height. What do we know about this ball? We know that it begins at ground level. We'll set that to be a height of 0 meters. This object also returns to ground level and will end with a final height of 0 meters. The object is given an initial speed VO that is aimed in the upward or positive direction, so I'll use positive VO as the initial velocity variable, and this object is accelerating due to Earth's gravity. It is a variables-based question, so I will use negative g for the acceleration variable. As mentioned, I am solving for time, so I'll put my question mark next to the t variable, and that would leave the final velocity as something that I don't care about for this question. I'm not given information for it, I'm not solving for it, so as I look over my equation options, I want to pick the equation that avoids the final velocity variable, and that's why I'd be selecting equation 2. From there, I just need to plug in the given information from my list. That is what I'm doing in this line. To make it look a little nicer, I'll change plus 1/2 negative gt squared into minus gt squared over 2. And now I can take this negative term and add it to the other side. Doing it this way makes it stand out that we can divide each side by t to eliminate one of the t variables on each side. And now I just need to perform the algebra, rearrange the equation to get the t variable by itself, and that would give me the final answer of 2VO over g. Notice that I've written t in terms of the given variable VO, and then the constants 2 and g. If you found this video helpful, then please consider hitting the like button and subscribing to my channel. You will help me reach more students. For more content videos, tutoring information, practice materials, and live review sessions, check out my website or follow me on my social media platforms.